me kind of resize this. So we're going to start with comments today. I know I touched a little bit on this before. Let me just make sure that this is working. There we go. Okay. So I touched a little bit on comments yesterday. Comments allow us to, well, here's some examples. Comments allow us to do a number of things. They're useful for a number of different things. They allow us to leave text in our program that isn't evaluated by the Python interpreter, or not really in the same way that, you know, that logical text is, right? So it's not considered formal code, right? So you can do that. You can utilize that for several different purposes. Sort of most obvious one is to take notes as you're solving a problem. So you might like write pseudocode. So we had an example yesterday. We could write pseudocode for this algorithm example, which we didn't have time for. And hopefully you all thought about this a little bit, but I'll give you an example of this. So writing an algorithm to boil a box of spaghetti. So thinking of a success criteria, we might say, you know, at the end of it, we better end up with a bowl of spaghetti. Spaghetti. Okay, one eye. I can't spell spaghetti. All right, great. Off to a good start. So we better end up with a delicious bowl of spaghetti. So we're working towards that, and we're starting with ingredients. So first step would be to, let's say, get pan from under the stove. And I'm thinking about in my kitchen, right? My particular kitchen, keep the pans under the stove. Your mileage may vary. Get pan from under stove. Fill, that's a pot, not a pan. Excuse me. All right. Fill pot with water from the tap. And that itself involves placing pot under tap, turn on water filter, because we want filtered water, turn water flow on to fill pot, and then we could say place, we could boil water. Boil water, place, pot on stove. What else? Turn on the burner. Salt the water, right? You could, so we don't need to go on with this too much longer, but you kind of get the idea. So as you can see, I'm starting all these lines with a hash in front of it. I have a keyboard shortcut. I'm on a Mac. This is a shortcut that's worth remembering because it makes this really easy. I can turn this line kind of on and off, commented and uncommented. For me, it's Command and the question mark button, or the / key, question mark and /. If you're on Windows, I believe it'll be Control and /. And that should be the case for any editor you're on, whether it's Atom or VS Code or Replit, or Jupyter, I believe, also has the same shortcut. So that's a pretty universal shortcut. So that shortcut will just comment a line on and off. So here's one use for comments. You know, like if we're building an algorithm and we want to take notes on it first to kind of describe maybe a process that we want to undergo to achieve some goal, right? Which is having a bowl of spaghetti. So this is one use for comments. Another use is for providing formal documentation for a function, right? Now, this wouldn't be formal documentation. This is more like pseudocode, like algorithmic notation, vaguely, just very loosely. It's not formal at all. I'm just kind of taking notes to remind myself what I need to do. This can be useful. I know there are paradigms of coding, and you may come from a coding background, or somebody may have told you like you always want to comment your code and leave a lot of comments. That is the case in certain other languages. It is not the case in Python. In general, comments like this can stay if there's a real justification for it, but in general, like you'll just make a few comments to maybe to remind yourself of a few things, kind of clarify your thinking. You're taking notes, think about it as taking notes. And then once you're done solving the problem, by convention, you go back and you clean up every comment that you can't justify having around. Occasionally, you may write a line of code that isn't obvious why it needs to exist. And you might think, you might have this, oh shoot, I know I need to do this now, but I might come back and look at this in a week and think, why am I doing this way? But I know there's a reason for it, so you might make a comment like, this isn't obvious, but we need to take this step in order to accommodate for this other thing, right? You might take a note to explain a line of code that isn't obvious. Although fortunately, Python code, once you know how to read and write Python, and you're feeling comfortable as a programmer, generally Python is thought of as self-documenting language, where the code is more or less self-explanatory, right? Obviously, that's subjective and relative to how well you understand the language, which takes some time and practice. But given that certain understanding, leaving a comment in your code is more for like clarifying something that you think might not be clear later when you come back and read it. So yeah, so take that as you will. Another use for comments is, so you've seen me, let's just clear this out, right? So we have some valid Python code up here, and this I'm just using as, this is called a sanity check. Like you get your environment up and running, and then you just print something off just to make sure everything is working. So I'm just printing off hello, just to make sure that like I see this, and like if I run this and nothing prints to the console, then I know, oh, I've got to go make sure that my terminal is executing the right file, and then I'm actually going to see the output, right? So this is a sanity check. So I don't need this line of code anymore, but let's say for whatever reason I don't want to get rid of it right now, I can just comment it out and then leave that there. So a lot of times print, since it shows you something on the console or on your terminal, print is sort of regarded as a debugging line. It's there to help you debug your code and kind of ask questions of what's going on in the code, to interrogate the code to see what's happening in it. So occasionally I will leave a print line in my code commented out if I think, I might need to come back and maintain this function or add something to this function. And I've got a print line here that, in a certain place that's going to tell me some specific useful information. And I don't necessarily want to figure out where I want to put that next time I come back around. So I'll leave a print in the code, comment it out, and possibly also add a justification on the end, like uncomment to see such and such, whatever. I might make some little explanation, be like, hey, this why I left this here. So that's a good thing. But it's quite often that you'll be writing some code and you'll realize you have 2 or 3 lines that you wrote that you want to just comment out temporarily while you go test something else or while you do something else. And you don't necessarily want to delete that code. You want to come back to it like right away, but you just want to like put it aside for the moment without totally getting rid of it. So that's what comments are useful for. Another thing comments are useful for. Okay, cool. So we're looking at these comments that start with a hash symbol. So anything to the right of the hash is going to be commented out. So if I uncomment this line, so notice we have this hash here. So when I uncomment this line, this comment part, this text part is actually still commented out. So that still stays commented out, and I can uncomment this line, comment it out, and yeah. So everything to the right of the hash at any point on the line is going to be part of the comment, right? And then if I come to a new line, oops, I'll come down to a new line, I can say print, right? And I'm back writing code because that line ended. So the next line is not commented out, right? Cool. So occasionally you want to write a short paragraph, or there are standards for sort of pre-existing standards and conventions around writing documentation in line. What I've been showing you, what I've been talking about, wouldn't necessarily really be documentation, more like notes and things like that. But there are formal documentation standards, right? And Python will allow you to do this, or write a short, or whatever, a paragraph in multi-line comments as well. So the way we make a multi-line comment is, I'll just do this from scratch. It's probably pretty obvious, but we'll use triple quote marks. So these are the quote marks on under my right pinky, to the right or the left of your enter key, your return key. So you do triple quote marks to open it, and then another triple quote marks to close it. And now I can spread this across multiple lines. I can say multi-line comment, right? So I can use either single tick quotes with just the one tick, or the double ticks. 1, 2, 3, 1, 2, 3. Multi-line comment. So often you'll see this. I use multi-line comments a lot when, let's say I have a problem statement. A problem statement will usually take the form of asking you to write a function. You'll see this a lot in Learn, and if you go on Code Wars, that as well. But we'll ask you to write a function, and I'll usually put it in, I'll put it in my text editor just so I can kind of work all out of my text editor, and I'll put it in a multi-line comment, and I'll do something like describe. So I'll write a short description of what the function is supposed to do, description of what it's supposed to do, and then I'll talk about what its arguments are, or its inputs. So what information it needs to take in, and what information it needs to give back. The word we return for, or the word we use to talk about what a function should output is return. And the word for inputs that we often use is argument. Arguments. So we'll talk about the description, and then its arguments, which are akin to inputs, and then the return, which is akin to outputs. So I'll obviously kind of fill these out more with something meaningful. So then you can include this inside the function, and Python will actually treat that as internal documentation and allow people to easily consult that. So if you ever build a library of your own code that you want to share and utilize, you can have this internal documentation that can be easily read by a Python parser. Cool. Okay, so basic Python constructs. Well, let's talk about the data types, simple operations, and the assignment operator. Just come down here. Just putting these hashes here as a visual separator so you can kind of see, that section is sort of done, and we'll move on. Make sure I don't have any code up here. Okay, good. Okay, so common data types. So while you're programming, you deal with data in many different forms. You might deal with text, and you want to deal with the text in a different way than you would deal with numeric values, right? So for example, if you want to do math, you have to have numbers. So 5 times 3. Let's print that out so we can see it. Oh, 15. There we go. I was like, come on. It's working fine. One thing real quick here. Let's just ignore the man behind the curtain. Okay, sorry. I just want to get a little space here when I run my code. That's going to clear the terminal, give me some new lines above so we can see the output more obviously, more clearly. Cool. So these are numbers. This star operator is obviously the multiplication operator. Kind of learning to use Python as a calculator. This is kind of nice. Whenever, it's funny, like I used to like use a calculator on my computer or whatever, like a graphical calculator. If I ever need to calculate anything, I just go to my terminal, start up a session of Python interpreter and of IPython, and just like use Python as the calculator because it's the best calculator in the world. So you can already use this, if you need to do any calculation, you can already use Python for that. Cool. So plus, minus, multiply, divide, these are pretty straightforward. 5 over 3, 5 star 3 is 5 times 3, right? So we'll run that and print it out. Cool. All right, so all of these numbers are considered integers. Their type is considered to be an integer. And that's because they're integers, right? They're whole numbers. So if you recall, an integer is a whole number value. It can be positive or negative. You can have positive or negative integers. If you look at this, Python considers this a different data type. So this is not an integer. This is what we call a floating point number. In non-programming vernacular, that's just a decimal number. So we don't use the term decimal to describe this kind of number. We use the term floating point number. Cool. We also have several other division. We have 3 operators related to division. So let's see, and I just went over this in study hall. It's kind of funny. Let's do 20, 20, 20, okay. Oops, not 520. Okay, so we have regular single slash division. Then we also have floor division. We call it floor division. That has, we use 2 forward slashes, regular slashes. And then we have another operator that is related to division. You can think about it as the remainder operator, but we use the percent sign, the percent sign like this. So this is not percentage. It has nothing to do with percentage. It's for getting the remainder of a division operator. We don't call it the remainder operator. We call it the modulo operator. I'm not going to get into why that is. You can look up why is it called the modulo operator if you want to do that. But for now, all you need to know is that it's called modulo. It uses the percentage symbol, what you're used to using as the percentage symbol, and it gives you the remainder. So you can think about it as the remainder operator. So let's look at this. If I say 20 over 3, that's going to give me this exact value. It's going to try to be as precise as it can. Obviously, it sort of rounds up right here. And that's not because it's like, well, you get the, it's not Python saying you get the picture. Well, I'm just going to, round it up and call it 7. This is a precision error. So it tries to calculate it as precise as it can until the CPU can no longer be that precise. And then it's a rounding error, and the calculation ends right there. But that's fine because that's really, 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 really precise. Although, your computer has a finite precision that it can accomplish. We have floor division here. So if I do, oops, and this is actually messed up here. Let's comment these out. So it'll be 6.6. This will be 6. And this will be 2. Okay. So these last two, if you learn to do long division by hand, these are the kinds that of quotient and remainder that you get from that kind of long division, right? So this tells us that 3 goes into 20 6 times with a remainder of 2. So there's 2 left over, but it goes into 26 times. So yeah, it is, I think it's easy. I just want to plug this for a second. Apologies if you were in study hall, you're hearing me say this a second time. Excuse me, I just called it the remainder operator. The modulo operator is important. I think it's easy to overlook. It's easy to look at these and be like, oh, well, I know what these first 4 are. We all know what these are: plus, minus, times, divide. I think we all have this like really, really well ingrained in us. And remainder is not that far off, but it might seem a little dense. Like, well, it's called the modulo operator. It uses the percent sign. It's just a remainder. There's nothing else fancy, or there's no other weird nuance about it. It's just a remainder. You could think about it as a remainder operator if you want, but I will be calling it modulo or mod. So the way we would say this, the way I would speak this is 20 mod 3 equals 2. So 20 mod 3 equals 2, or 20 modulo 3 equals 2. So this is extremely useful, as it turns out. It is worth remembering, for going over this material, because you will encounter it and it will be very useful. Cool. So that's integers and basic operators. We can also do the same operations with floating point numbers. So let's just look at floating point numbers. 9.0, 0.0, 1.2, negative 3.5, this point, that. These are all floating point numbers. And you can see they're all numbers that express a decimal value in some way. Even 0.0 is considered a float because it's 0.0, right? We could have 0.3 or 0.2 or whatever. 9.0. Now, this is a whole number value, but it's not an integer. Integers are always whole number values. Floats can have the same literal numeric value, which this is equal to the integer 9, but it's equal in value, but not equal in type, right? Now Python's pretty forgiving about this. You may come from a language that if you're doing some mathematical operation with an int, you can't combine it with a float in some way. Python, like I said, Python's very forgiving about this. You can use integers and floats in combination in mathematical expressions. you'll probably get a float back, which may or may not be a problem. So for now, like it'll become obvious why it's important to make a distinction as we learn more. For now, just remember that there is a distinction, and like I said, it'll become, if it's not obvious why there's a distinction being made yet, it will become obvious once we get into lists and stuff. Cool. We also have, so we covered int and float. Let's talk about Boolean, or bool for short. So Boolean operators, or excuse me, Boolean values are, Boolean's simple, it's just true or false. Excuse me. You have to spell it with a capital T and a capital F, so true or false. So there are only two valid states for a Boolean expression, true or false, and that's it. So it's nice and easy. There are lots of things in Python that evaluate to a true or false expression, right? So I can compare two numbers. There's a set of operators sometimes called comparison operators, sometimes called Boolean operators. So I can compare two numbers in terms of whether one is greater than the other or less than the other, or they're equal, right? So if I want to say print, is it true or false that 6 is greater than 4? That's true. We know 6 is greater than 4. Cool. Is it true or false that -6 is greater than 4? That's false, right? And I can say greater than, I can say less than, I can say equal to. When we're comparing equality, if two things are equal, we use two equal signs. A single equal sign is reserved for something else. We'll get to that in a second. But we use two equal signs when we're comparing equality like this. 6 equals 4. Obviously, that's going to be false. 4 equals 4. That'll be true. We can compare if something is not equal, and that'll just be the inverse of whatever equal tells us. We can also compare if something is greater than and equal, or less than and equal, less than or equal, excuse me. Greater than or equal, or less than or equal, right? So these are just variations. There's some overlap between what these operators do, but these are what you have at your disposal for comparing values. You're not limited to just comparing integers, as I'm showing. You can compare Booleans to Booleans, or numbers to numbers, ints and floats. You can compare an int and a float, right? So we could say is -6.3 greater than 4. Even though these are different types, Python is smart enough to know the value 6.3 is not greater than 4, so that's false, right? So that kind of expression works. You can also, so these are useful for comparing. Excuse me, these are useful for comparing numeric values. Good. The assignment operator. Okay, so this is where things start to get a little more interesting, I think. We can save the results of an operation into a name, which we call a variable, right? So let's create a variable. Let's just say x equals 5 plus 3. And we could even be, let's just say a equals 5 and b equals 3, and we'll just say a plus b. So x is a plus b, so let's print x. Cool, okay, so what happened here? So I said a is a variable that has the value of 5, b is a variable that has the value of 3, x is the variable that has the value of a plus the value of b. A's value is 3, excuse me, A's value is 5, B's value is 3, 5 plus 3 is 8, 8 is the value of X. So creating variables is a useful thing. You can kind of break out, do a small operation and then save that into a variable and then use that in another small operation. So it can help you kind of think through things in smaller steps without like having one line that grows and grows and gets more complicated. So that's also a useful one. Again, to see the results, we can use this print function, which will help us visualize what we're doing. Okay. There's another really useful built-in function called type. We're talking about data types. We just went over 3 data types. We went over int, float, and bool. So let's say I have, okay, so let's just pretend a little bit. Let's say everything above this line is from some other file in somebody else's library, or I don't know, some other piece of information somewhere out there that I can't necessarily see right away. So we'll say z equals 10, right? And for whatever reason, I want to know what the type of z is. I can print the type of z. And you can see it's going to say that this is a class int, right? Remember I said a number like this is called an integer. Python just calls it an int internally. So if you ever want to know what Python's internal identifier name for a type is, you can just pass it to type and it'll tell you. So in this case, z equals 10, type z is int, right? So if I can pass a literal number to this as well. So 4.3, the type of 4.3, excuse me, is float, a floating point number. Cool. So that's another really useful function to know as well. We talked about, oh yeah, this is worth mentioning. If you remember PEMDAS, if you learned PEMDAS order of operations at some point in school or whatever, Python follows PEMDAS. So what is PEMDAS? PEMDAS is parentheses, exponents, multiplication, division, addition, and subtraction. Let's do this. I just thought, I'm not entirely sure of the division operators, which one is evaluated first. I'll have to test that and find out, but these are the division operators, and I know all 3 of these fall in this category, although I'm not sure how they're broken up or if that matters, but I think generally it basically doesn't matter. But yeah, so mathematical expressions are going to obey an order of operations that you're familiar with if you're familiar with writing and understanding mathematical expressions. And if you're not, in my opinion, Python is a great way to familiarize yourself with such expressions. It can really help solidify that knowledge because you have an interpreter that'll tell you if you got it right. Duck typing. Okay, so we're talking about data types. Every programming language has data types. Every one that I'm aware of. I can't think of how to have one without it. Every language has to have what's called a type system or typing system, right? There's a system of how the language understands and handles and assigns types, and if or when it can reassign types or convert one type to another. Python is pretty forgiving and permissive about that. The idea with Python is if some operation seems rational, then it should be doable, right? So we haven't talked about strings yet, but if I say hello plus world, you know, you might look at this and intuitively think, well, you know, this is going to be the word hello plus the word world. So this should give me a string hello world, which it does. We'll talk about more about strings later, but strings are the Python's way of representing text internally. So Python can handle dealing with text. So strings are another data type, but hopefully that's intuitive why that works. So the idea is if some operation seems doable, if it seems rational, then it should be doable. So i.e., if it walks like a duck and it quacks like a duck, then it must be an integer or something. I don't know, but that is why it's called duck typing. It's literally if it walks like a duck and quacks like a duck, then it must be a duck. That's why it gets its name. A lot of languages use duck typing. Python uses duck typing. JavaScript, I believe Ruby and Perl also use duck typing. Might be wrong about Perl, but yeah, a lot of common languages use that typing system. So just good to know. Okay, cool. I totally forgot to mention the homework from last night. So go through this stuff. I'll just roll this in as part of today's homework, and I'll slack out a reminder at the end of class for people to do that. Cool. We can move on to day 2. All right. So this kind of covers some of the stuff we just talked about. Common data types, simple operations in Python, assignment operators, and scalar data types. Okay, so the numeric types, just a quick review of what we literally just did. The numeric types that we just talked about are int, float, and bool. Bool is considered a numeric type even though it has only 2 states. There are times when true can be understood where Python will sort of intuitively understand true as a 1 and false as a 0. It can also understand numeric values as Boolean values in other circumstances as well. But yeah, it's a little counterintuitive that Boolean is considered a numeric type, but it is for whatever that's worth. So int and float data types are encoded differently. So the way it's funny if you really look into the way that Python handles representing and managing integers and floating point numbers, it's real different. To us, it's like, well, you got a number and you got a number with a decimal in it. It's pretty easy, but to describing what that means to a computer, it turns out is 2 very different descriptions. So it's pretty miraculous that you can have math that can be exist across both types. But I mean, really, it just involves converting integers to floats. That's sort of the shortcut. But anyways, so they're encoded very differently, but are able to share operations, i.e. duck typing, right? So if I want to, I believe I just demonstrated this, but why not demonstrate it again? So 4 plus 6.3 or whatever will be 10.3. Cool. So keep note, though, that these are equal, these are, what am I saying? These are equal. These both express a numeric value that can be rationally combined, right, in terms of comparing or doing mathematical operations. So the example 4 equals 4, obviously that's going to be true. 4 equals 4.0. Go ahead and put it in Slack. 4 equals 4.0. Is this going to give me true or false? We got a question here. Sorry to keep you all waiting. Oh yeah, there are. Somebody saying they're surprised that Pemdas goes by another name in other countries. Yeah, I've heard of alternative orders of operations too. And it's kind of funny if you dig into that. It's like the reasons why order of operations works the way it does is pretty interesting. Cool. Yep, cool. So this is true because we're comparing the value 4 to the value 4.0. These are the same value, right? That's not that hard. I just wanted people to type that in just so you solidify it. Okay, we're comparing value. Comparing by value, right? You might think, well, what else could we compare? We could compare the type. So is this going to be true or false? Is the type of 4 equal to the type of 4.0? Yep, bingo, y'all got it. So this is comparing by type. And this is a valid thing to do. Python, Python totally allows you to do this. It's totally fine. We can see that's true, and this is false. It's totally fine and very useful. Sometimes you want to compare by type, not necessarily comparing for equality sometimes, but often you want to compare for type. Well, yeah, for equality or inequality, or you can check if a type is a member of some list of types or something like that. Simple operations, we just went over most of these. I forgot to mention the casting. So casting, when we use the word casting, a lot of times we mean, you could understand it as converting one type to another, but the word we use is casting. So let's say I have a float. My float equals 5.3, and I want it to be an integer. Let's say was a float. I'll say int my float. And I just realized I should probably explain this. This might look a little funny at first. The underscores don't mean anything special. It's just a way of separating the words. So the underscore is a valid character for a variable name. Yeah, so but Python uses a casing convention or a naming convention called snake casing, which just means that you separate words with an underscore. So that's what I like to do. So my float equals 5.3, and then this variable was a float, or that's a dumb name. Let's just call it num equals int my float, and let's print it off. Right? So quick question, what would happen if I printed off my float? What's the value of my float going to be? How about 4 equals 4? We got another question here. Go ahead and put your answer in for this question. Somebody's asking, print 4 equals 4. Like this. I'm typing it as you had stated it. So 4 equals 4. This is actually going to give us an error. So it's a name error. It says name 4 is not defined. So it looks at this and it sees 4. The way it sees it like this, it's expecting that it's a variable called 4, but I might have a variable 4 equals 4, and that's going to be false, right? So if I made that a string, that would also be false. That would not be equal. Cool, let's see what we got here. Oh yeah, you did give an example with a string. Yeah, so 5.3. So that's good. I just wanted to test people's intuition on this, just see where people are at. So notice we cast this my float as an integer and save the integer value in num, but that doesn't change the value of my float. That just gives me the integer version of it, right? So I can do the same thing if I have, let's say, FLT for float equals float of num, and then print float. So what's the value of FLT going to be? Excuse me. Go ahead and put that in Slack. Oh, sorry, the value, not the type. Yeah. Cool. I'm getting a lot of 5.0s. And somebody said float, and it will be a float. Cool. So here's another little trick. If you have a floating point value and you don't care about the decimal place, you just want to round it down to, you just want to truncate the decimal value and round it down, you can just cast it as an int, and you'll lose that floating point precision, and you'll end up with just the integer portion of the representation. So that can be a useful trick. So that's casting between ints and floats. Basic arithmetic operations. Let's see. I think we went over these. We're doing pretty good. All right, we got a breakout. So I'm going to paste these into Slack, and go ahead and paste in your answers into Slack. Oops. Let me make sure. Print. Let me actually format this so it's nice. Okay. And I'm going to just put like 2 minutes on the clock. Let's see how long should this be? Yeah, this is a 2-minute breakout. I'll just put 2 minutes on the clock here and go ahead and put your answers in Slack. And I see some other questions here. So is there a way to minimize a float down to a certain number of, presumably you mean a certain number of places after the decimal place? So for example, 3.14, there's a function called round that you can use that has this behavior, if I'm understanding your question right. We can look at that after the breakout. That's a good question. All right, go ahead and get your answers in. Oops, don't want to do that. Apologies. There we go. I wanted to show some examples for round since there was a question on this. So I just have some numbers here. We got 3.442. So if I round this 3.442, and I pass it to this round function and print out the result of round, we get 3. So this is, for this particular example, this looks like it behaves like int, but it doesn't quite. So let's do this. Let's compare it to the behavior of int. Okay, so I'm going to do this one and this one as int. Okay, so if it's 3.44 something, round is going to round it down and I'm going to get 3. Int is going to round it down and I'm going to get 3. But if it's 3.9 for something, right, then round is actually going to round up. It's going to round to the closest place, right? So it's going to round up, and int is going to still round down. So int always rounds down. No matter how, this could be 3.99999. There actually is a place where you have so many nines that Python can't actually distinguish this number from the number 4, which is kind of interesting, but we're not going to go there right now. Okay. So we should get 3, 3, 4, 3, and that's what we get, 3, 3, and 4, and 3. So round will round to the closest place. That's if you pass just the number, right? So if I pass a float to round and I pass only the float to round, that's the behavior that it will have. So round can optionally take in a second number, right? So we're using this round function and it can take in 1 or 2 inputs. If it takes in 2 inputs, the first input has to be the float, same as the previous, has to be that same float, the thing to be rounded. And then the second input is the number of places expressed as an integer. So the number of places expressed as an integer to round to, right? So if I want to round whatever num is, if I want to round it to 2 decimal places, I can say round num 2, and that'll round it to 2 decimal places. So yeah, that's interesting. You can go play around with that, but that's a play around with that. Oh my God. The puns, I don't even need to try anymore. They're just in my subconscious taunting me and making everybody's lives miserable. I'm so sorry. Go play around with round. I'm just gonna embrace it, my condition, my pun condition. Okay, whatever. Cool. So that's a good function to know. All right, let me get Slack back up on my phone. Excuse me. You can look through the slides for solutions to these. I'm going to assume that all of you are doing good and we're able to get this. So floor division. So the floor division truncates everything after the decimal, gives an int. If both data types are ints, returns the quotient of x divided by y. So notice, look at these examples. Float will give you, sometimes will give you a, what do they say float? Floor division or double slash division will give you a floating point number depending on the inputs, right? So if you're dividing a float by a float, notice that we get a whole number expressed. This number could be expressed as an integer. However, one or both of its inputs were a float, so it's going to express it as a float. So it's sort of like, well, you know, a float is a objectively more complicated type and can express all the numbers that an integer can express. A float can also express and an infinity of numbers more, you know. So something like this, 76 or 72.6 4 divided by 3.3 is 21.0. So you still get a float back. Most of the time that I think to use floor division, a little trick that I end up doing, usually the reason that I want to use floor division is specifically because I want to end up with an integer, not just a whole value, but specifically an integer. So one thing you can do to recuperate a lot of the same or all of the same behavior and standardize this as an integer, you can do, let's just say A equals some number and B equals some other number. Could be anything. And let's print int A over B. Right, so this is a lot like floor division, except you're explicitly saying, hey, whatever the inputs are, just convert it to an integer after you're done. And I don't care about the rest. So this is a kind of a way of modeling the behavior of floor division, but you always, always, always get an integer back, which can be useful. So you'll see me do this a lot of times where you might think, well, couldn't you use floor division there? But I end up doing this. And I'm not saying you should never use floor division, but I'm just saying you might see me do this, and it's something to consider in addition to floor division. So modulo, we talked about, it's the remainder operator. Let's say we have a number and we want to see if that number is even or not. This is actually giving you the, this is actually this example. So Yeah, so if we want to see this number, if this number is even or not, true or false, right? It's either true or false that the number is even. So we can say print num mod 2. So if num divided by 2 equals 0, so this is, remember, this is our equality operator, right? So we're saying if num over 2 is equal to 0, then that means 2 is a factor of num. 2 is a factor of num, which means that it's even, right? So since we have this comparison operation, you can look at this as giving a true or false value back, right? And again, this is sort of PEMDAS. We could be explicit about this. We could say, evaluate num over 2 and give me the remainder. And if that remainder, whatever that equals, is equal to 0, you know, check it. If it's equal to this thing, which is 0, then true or false, right? So it's 43 mod 2 equal to 0. Obviously, it's false because it ends in a 3, right? But let's look at 44 just because we're here. And why not? And obviously, that's going to be true. Cool. So this is a really useful thing. Very often, you'll need to see, you know, you'll be dealing with a collection of numbers, and you'll need to see, is something in this, is something a factor of something else? Is A a factor of B? Is some number from an array of numbers, A sub I, a factor of some other number B, right? It can be really useful to build lists of factors and know what the factors of something are. So modulo is, like I said, very useful. It's good. Modulo with float values. This is weird and has some unexpected behavior. We're not really going to cover it other than to say that it's weird and it has some unexpected behavior. You don't need to worry about understanding it fully at this point. Yeah, just it's something that you would use if you really know what you're doing, and it's not really something that's going to come up. I can't say that I've ever really had to do modulos with float values. Other than to just play around with it just cause. In real life, I don't think I've ever had to do that. Same thing with negative modulo, also some sort of confusing and unintuitive behavior here. So just know that you can do it if you needed to, but again, not sure that that's ever come up. We're about halfway through class, a little over. Let's take a 5-minute break. So let's reconvene at 10 after the hour. Yeah, we'll pick up at 10 after the hour. Cool. All right, we've got about half a minute left. All right, cool. I'm seeing people popping back on. Hope you had a good break, nice stretch, grab some water or something. All right, let's jump back into it. I'm going to assume everybody's seated and situated and ready to go. So we do have some questions here. Looks like this one got answered, but I want to show an example of this. I don't want to, not to put you on the spot, or I'm not trying to call you out or something. It's fine to like get this particular thing wrong. You will see me probably make this mistake as well. This is, I just wanted to bring this out. The question was, you probably all can see it, but can I clarify why these two, lines? So this line will throw an error in the interpretation, while this line equals 20. So notice one thing. If you look, here's something you get, put some time into getting used to the way your syntax highlighting looks. So I know that my functions highlight in this sort of blue color, and if I look at this, the highlighting looks off to me. So that's a sign that I have a syntax issue. Another thing is, you run your code, you get an error, that's fine. And I'm going to show you how to read the error real quick here. So I'm going to show you, this is how it's going to look in Replit. Well, this isn't too long of an error. This is a nice short one, but a lot of times you'll see all this error text up here. And I think the sort of thing that you think you want to do is to start at the top of the error and read your way down line by line like you would anything else. One of the reasons I have my terminal here at the bottom, whoops, split that and didn't mean to, is I generally don't care about anything other than the last few lines of the error. And the reason I have this terminal where it is to read the last few lines of the error, because generally that's the most useful information. So in this case, we have this nodemon thing, which is my file watcher, and that's not important here, but this is the end of the Python error. This is the last line of the Python error. And it says, syntax error, unexpected EOF while parsing. If you get a syntax error that says unexpected EOF while parsing, I think every time I've gotten that error, it's because of an unmatched parenthesis. I think every time I've gotten the error where it says unexpected EOF while parsing, EOF means end of file. So you have to watch out for that. And I just wanted to point this out because it's a really good example of like sort of an optical illusion, right? I have two parentheses here, okay. I have two parentheses here. My eye automatically matches those two, the two on the left, the two on the right. So it looks correct, right? And it's weirdly easy to think about or forget about that I have this extra parenthesis here. So I've got one opening, two opening, three opening parentheses, and I better have three closing parentheses, 1, 2. So I have only 2, right? So either this one has to go or this one has to go. So yeah, you could, well, either that one has to go or we have to add another one there is what I mean. You could do either one. What I'm a fan of doing to combat this is, this ties into the other question that was asked. Somebody else asked white spaces about white spaces around operators. Is it better to say like 3 plus 4 with no spaces, or 3 plus 4 with spaces? By convention and by my personal preference, and I think you'll find that it's more readable to put spaces between things. That is the Pythonic convention, and that is also what I'm going to do because I think it makes things more readable. I do something additional to this, which is not specified as a Pythonic convention, but I think it aids in readability. When I'm doing anything with nested parentheses at all, I'm going to put spaces around the matching parentheses, right? And that's going to help give me visual relief, right? So let's look at this again we can see, like if you look at this, it's kind of an optical illusion. We know there's a problem with it. We just discovered what it is, but it still kind of looks right, which is the problem. But if I go through and I go, okay, so if I put that there and this here, it already is more obvious that there's a problem. Like visually, I can see it, right? I can see, okay, so these two match, and then this one opens and closes, but this one never closed, right? So in order to combat this, I will put spaces sort of inside my parenthesis groups in order to kind of spread things out and to make it clearer what groups are, where a group begins and ends, and what group is inside of what other, or what set of parentheses is inside of what other set of parentheses. So that's something that I do. You don't have to do it, but makes things, in my opinion, makes things more readable. And being dyslexic, I'm all about that. So anyways, hopefully that gets those two questions. Those are good questions. And again, I don't want to I'm not answering those. I think at least one of those was answered by another student while I was talking, but I'm not trying to put anybody on the spot. But they're good questions, and these are issues that are common enough that I think it was just worth covering. So yeah. Oh, we got some more here. Excuse me. Does the code depend on interpretation? I'm not sure. I'm not quite sure what that means. The interpreter parses and validates the code to make sure that it's valid code and can be interpreted as Python code. If you don't mind reframing that question. Oops. Okay, I'm lost. Did that question get deleted? Am I okay? Sorry, I'm swimming through Replit, Slack here. Okay, in Replit, the error says mismatch parentheses. Okay, yeah, sometimes you'll get a slightly different error. Okay, if there's an outstanding question that I haven't got to, I'm not seeing it. I haven't read through everything. I want to move on. If you want me to answer it, that's fine. Just put @Clark in front of it, and I'll know to see it and answer that question. Apologies, but I do want to move on. Okay. We got another breakout here. Okay. And I'll put 3 minutes on the clock for this one. Do your best. Don't worry if you can't get through the whole thing. Just paste in whatever you get at the end of 3 minutes, or if you finish before, then paste it in. That's fine. But if you want a reference to compare your solution to, you can do that. Whoops. Excuse me, what was that? Okay. All right. This is just a review of comments. We can skip that bit. We literally just went over that. Casting, assignment operator, incrementation operators. Okay, so we talked about creating variables before. So let's say I want to create a variable that like counts something as my program executes. Trying to think of an example. Yeah, I can't think of an example that's not just that isn't more complicated than we should give right now. But let's just say I have a variable x equals 0, and I want to modify this value. I want to use it for counting something. Something happens in my program, and I want to count that as an event. I'll store it in the variable x. I want to say x equals 1, but I don't necessarily want to just say x equals 1, because I might not know, maybe I might not know how many times I want to increment x, right? I might just want to increment it by, compared to its current value, right? Because what if x is already equal to like 3? Well, I just reassign it to 1, which doesn't really help me with counting, right? So if I want to count, if you think about counting, right, like the next number is equal to the previous number plus whatever the increment is, right? So I could say x equals its current value, so x equals x plus 1. So this is incrementation, right? This is such a common thing to do. It's really something that you do all the time in various forms. It's such a common thing to do that Python has a shorthand for this, and that's x plus equals and then the increment. So Python will turn this, like the interpreter sees this line of code and it literally turns it into x equals x plus 1. So yeah, you can do this and it'll be exactly the same as x equals x plus 1. You can also do this with you can do this with subtraction, minus equals 1, times equals 1, divide equals 1, floor divide equals 1, mod equals 1. You could do exponentiation equals 1, or exponent equals, or whatever, 3. And some of these are hard to think about. But if you ever see one of these that's harder to think about, you can think about it like x equals x to the third, right? So that's how that's going to be rewritten. This is going to be rewritten as x equals x mod, let's do 2, I don't know. And then this is going to be rewritten as x equals x floor divided by 3. Make that 3. So if you ever see one of these and you remember, oh, well, that's a incrementation style operator, but it's still not clear what's happening, just rewrite it or think about it as x equals x over 3, right? So it's equal to whatever its current value is, and then combined with that operation. Yeah, let's just finish this off. X equals x times 2, and then x equals x minus 1. Cool. I want to show you another built-in function. So we've looked at a few built-in functions today. I believe we've looked at, well, you've seen me use print a lot. Anytime I want to see something on my console, the result of my code, I'm using print. So print's pretty useful. Makes things visible on the console. We've talked about type. And we actually have to print out the type in order to see it. So we can say print and type. We can print the type. But we can also use type in other contexts that's not necessarily print. Oh gosh, I feel like there's another one that I went over. There's just print and type. Oh, round. We've also talked about int and float. So here's some functions that we've talked about. I want to add in another one, ID. So ID essentially shows you, it gives you back the identity of a value in the program's memory, right? So you can think about it like it gives you back a location in memory. It's not quite what it does, but it's a good way to think about it, right? So this is going to tell you the ID of 4 or 34. Let's do that then. ID of 34 and the idea of 35. Print these out. So these are the IDs. If you look at the right-hand numbers, like the last 3 numbers or whatever, you can see that the first one ends in 344. Excuse me. And the second one ends in 376. Three, 4, 4, and 376. So that tells us that these are different. These are not the same thing, which is kind of a tautology with this example. So I'm more showing you this so in order to reintroduce it later, it'll make more sense why it's important to see if 2 things have the same ID or not. When we get into mutable types, that is, types that can have their values change, right? So you can't change 34. You cannot change the value 34. Like 34 is a number. Like, what are you going to do to change it? You're going to change it to 35? Well, now it's just 35. You didn't change 34. 34 is still 34. 35 is 35. So they're different values. But there are other types, sort of more complicated types that represent collections of information. So you might have a collection that starts empty in your program and grows over time, right? But it's the same collection, even though the value changes, right? If you add an item into the collection, the value changes because it used to be empty. Now it has an item or it has another item in it. So the value changes, but it's still literally the same item, at least as far as the program is concerned. As far as your memory model in your computer's RAM is concerned, it's the same bytes taking up the same space in memory, or at least it has the same ID, right? So apologies if this is not entirely clear, but we do like to introduce it early. This idea of ID, it'll take a while. This idea of what an ID is in your program. So we'll be revisiting that later. If it's not entirely clear, then just tuck it away for later. So scalar types. So what is a scalar type? A scalar type holds one single value. So what I described with integers sort of describes a scalar type, right? It holds a single value. So far, we've only dealt with scalar types, integers, floats, bools. some scalar types we haven't talked about are strings, none, complex, and bytes. We're not going to cover complex and bytes in this course. You can look more into these at your own discretion, but we are going to talk about string and none as well. Integers are positive, or excuse me, integers are positive or negative whole values, whole number values. Can cast scalar types as integers using the int function. Use the int or float function always rounds, or using int on a float always rounds down to the nearest integer, always down. Floats are what are usually called decimal values. They have a decimal point in them and can represent decimal numbers within a finite precision. There's an odd phenomenon, we've seen it a little bit with floats, called underflow, which occurs when trying to represent a number that is smaller than the computer can represent within the amount of binary registries that are allotted to representing floats in Python, which I think is 64 bits, if I'm not mistaken. Correct me if somebody knows, correct me if I'm wrong on that. Cool. So underflow, let's look at, I kind of alluded to this a little earlier. If I have 3.9999999, this is saying, the copy here says when the number is smaller than the computer can represent in binary. Instead of smaller, I'd say when the number is more precise than the computer is capable of being, right? So this is giving me 4.0, and it's not because Python's like, hey, that number is really close to 4. You know, I'll just do you a favor and round it up for you. It's not. There's no magic here that's intended to make this easier by rounding it to 4. It literally can't, like, to the computer on a binary level, it cannot tell the difference between this number and this number. These are the same number, according to Python. So true, right? So this is underflow. This is potentially something that you will encounter if you're dealing with float values that are really precise. This might be a limitation, and honestly might not, but just in case you ever come up against this as a limitation, just know that underflow can occur, and this can be a thing. It's not frequently a problem, although if you don't know that it can happen and it's causing you an issue, it can be really hard to figure out what's going on. So cool. Yeah, that's just something to tuck away. If you're dealing with a super precise floating point value and it's behaving weirdly, you may be up against an underflow error. Booleans are true and false, can be 1 and 0 respectively when cast to numeric types. Non-zero and non-empty values return true. We didn't cover Boolean operations that much, but there's some operators that are kind of interesting. Anybody who's taken like a formal like logic class might be sort of familiar with this. We can say not, so not true. You want to guess what not true is? Go ahead and guess. I feel silly even asking, but I'm asking. False. Yes, not true is false. We also have and, right? So and is going to let us, you know, you can imagine these, imagine wherever I'm saying true or whatever, or true or false here, that it's a stand-in for some expression like, what did I have before? Like num mod 2 equals 0 or something, right? You know, so we say num equals 4. So num mod 2 equals 0 is going to give me back a Boolean value, right? Num mod 2 is going to give me back a number, and then equals 0 is going to give me back a Boolean, right? So it's going to say, does whatever the number that this gives me back, is it equal, true, or false, equal to this other number? That'll give me 0. Or that'll give me a true or false. So you can imagine wherever I'm writing true or false here, that either some kind of expression that's evaluating to true or false, right? So true and true is true. False. So true and false is false. False and true is false. False and false is false. So and only gives back true when both its left and right hand values are true. If either one or both is false, it's going to give back false. Likewise, we have or. True or true is true. True or false is also true. False or true is also true, and false or false is false. So these are, if you, like I said, if you've taken a formal logic class, you might recognize these as truth tables, and that's basically what these are, is truth tables. So not negates whatever, not true is false. Not false is true. Okay, cool. There's your truth table. So those are good. These are good operators to have memorized. Okay, strings. Let's look at strings. So strings are our first non-numeric type that we're going to look at in any depth. And I did bring these up a little bit ago. So strings are Python's data type for representing textual information. So hello world is a string. My name is Sammy is false. That's not my name, but yeah, so these are strings, right? So the way we can create a string is we can use single tick quotes or double tick quotes. PEP8 convention specifies single tick quotes for strings. So just to be clear, there's no difference between hello world with double tick quotes or hello world with single tick quotes. Python sees the two as exactly the same. PEP8 and most Python code follows the convention of using single tick quotes, and that is specified in PEP8. I prefer to use double tick quotes because I find myself writing things with apostrophes in it more often than I do things with double quotes in it, right? The thing is, the apostrophe character is a single tick quote, right? So if I said like there's a house over there, right? So if I said this sentence, right, there's a house over there. If I put this in double tick quotes, this apostrophe is just going to be another character in the string. If I put it in single tick quotes, it's going to think that the string ends right here and then I'm going to need to go to the end of the string. Now there's a way around this. If you want Python to ignore some character in the string, you can put a backslash in front of it, right? So the backslash is called the escape character. So it's kind of like saying, hey, don't worry about that. Just treat it like the regular character, right? There are several useful characters that start with a backslash that you can use. So for example, if you want a new line in your string or a carriage return, you want the string to break on and print onto the new line or something, you can put a backslash in for new line. So there's things like that you can do. So it's important to know about the backslashes as an escape character. Convention, standard Pythonic convention is to use single tick quotes, and if you have to use an apostrophe, to use a backslash in front of it. I kind of think this is ugly, and I prefer to not do that. I prefer to use double tick quotes like this, because I find myself using apostrophes not infrequently. Yeah, you can make whatever decision you want. If you want to do it the way I do it, that's fine. If you want to do it the way Pep8 does it, that's also fine. If you want to experiment around and find out which way you like better, that's fine. The rule for good code formatting is not necessarily like you must always do such and such. It's more that be deliberate and be consistent. So experimenting to find out what you like is totally fine. I don't really have any opinion about this. You don't have to do things my way. But just, after some time, think about what things you like, what things you don't like in terms of your coding style, and make decisions about what you're going to do and do that consistently. So, and that will develop over time. It doesn't need to be solid, but it is something that's worth putting effort into, because it makes your code more readable, more maintainable, and prettier. Cool. So if I print these out, we'll see that they're going to be the same. Taking forever to run. Okay. There's a house over there. There's a house over there. Okay. I have a silly example. Like integers and floats and bools, we can assign strings to variables. So we can say my string equals hello, or let's say this. Greeting equals hello. So if I print that, if I print the variable, right, the variable has a value of hello, so it's going to print hello. I put a space after it. And then name. Let's say I have another variable called name, and my name is Clark. So I can combine let's say hi as a variable that equals greeting plus name. Right? I think we went through very similar stuff in study hall today. I can't remember if I went over it in study hall or at the beginning of class today. I think I just went over this in the beginning of class today, right? Like, oh, right, when I was talking about duck typing, right? So, we have two strings and a variable. We're adding them together. Seems like this should be doable, right? And it is. We can add strings together. When we use the plus operator to add two strings together, note that both types have to be strings, right? If the left-hand type is a string, we want to add two strings together. With the right-hand type also has to be a string. Same thing with numbers, right? You want to add two numbers together. Whatever the sum of 4 and poodle is a mystery. I don't know what the answer to that is, but poodle plus potato is poodle potato. So obviously. So say hi equals greeting plus name. If I print say hi, it'll say hello, Clark. Cool. Yeah, and we will be talking a lot more about strings later. They're a pretty simple or a pretty central and simple type. Well, there's a simplicity and a not simplicity as well. None is a value of no value, right? So sometimes you have, let's say I have a variable, and I know throughout the course of my program, there may be a reason where at some point A needs to be a string, and at some other point A needs to be an integer, or A needs to be a Boolean or a list or something, right? Like I don't really want to like start it off and bake in some value. So I can start it off at none, right? You might think, well, maybe you could just do this. Maybe you should just say A equals and then not put anything. This is going to give me an error, right? If I try to run this code, I think it might be an unexpected EOF. No, it's just an invalid syntax and it points at it. Okay, so A equals none, right? So now this is valid. It just doesn't, it's a value, none is a value of the absence of the other values. So there are times when this is useful. Y'all, yeah, this is a funny one. If I print the value of print, you know how I'm using print to see what all the other functions, what all of them give me back, like how round gives me back round gives me back this number rounded to the first decimal place. So round gives me this back and then I print it off, right? I mean, you might ask yourself, what does print give me back? See where I'm going with this? Print. So print, as well as some other functions, will give you back none. So print gives you back none. So print doesn't give back a value. What it does is it writes that value to the console. That's what print does. So there are a number of other functions and built-in methods and things in Python that don't return anything, that don't have an output. And if no output is explicitly given, Python will assume that the value is none because it has to plug in some value there. It has to have some value, but if it doesn't have another one that it's explicitly given, it'll just give back none. Cool. One second here. Oh, we are right at the end. Oh my gosh, we're gonna finish the material today. Isn't that wonderful? Here's the next breakout. Oh, I'm sorry. Let me actually re-paste that without garbage formatting. What is the result of, actually, oops. Okay, there, now it's nice and bulleted. So we've got just 2 minutes for this one, nice short one. There's your time on the clock, have at it. All right, there's your 2 minutes. Go ahead and get in what you got. Share your answers. Cool. Forgot to cover casting to a bool, but yeah, you can cast to a bool. So as I'm sure many of you have just found out. Let's just look at this right quick. So casting to a bool of, let's say 4 versus bool of 0, and let's say bool of 0.3, 0.0, and let's do a bool of a string hello, and a bool of an empty string. And let's see what we get. You can cast all of these to Booleans. True, false, true, false, true, false. Well, I didn't know it'd be that symmetrical. Okay. Cool. True, false, true, false, true, false. All right. Yeah, so take note here. Values equal to 0 are false. Values equal to anything not 0 for numbers are true. This applies to strings, but it'll also apply to other collection types as well. Collections that have contents are true. Collections that are empty here are false. Now take note, empty string is a valid string. It literally has a length of 0. There is nothing in it, but it is a valid string. It's valid to have an empty string. So, there's no characters in it. Cool. Come on. All right, and that's the last part for day 2. We've only got 2 minutes to spare, which is great.